Our planet Earth consists of four major spheres: the atmosphere, the biosphere, the hydrosphere, and the geosphere. And this is what we learned in our Earth science. The atmosphere. It is a layer of gases surrounding a planet or other material body that is held in place by the gravity of that body. The atmosphere of Earth is composed of nitrogen, about 7 to 8%, oxygen, about 21%, argon, about 0.9%, with carbon dioxide and other gases in trace amounts. Biosphere, also known as the ecosphere, is the worldwide sum of all ecosystems. By the most general biophysiological definition, the biosphere is a global ecological system integrating all living beings and their relationships, including their interaction with the elements of the lithosphere, geosphere, hydrosphere, and atmosphere. Hydrosphere is the combined mass of water found on, under, and above the surface of a planet, minor planet, or natural satellite. It has been estimated that there are 1,386 million cubic kilometers of water on Earth. This includes water in liquid and frozen forms in groundwater, oceans, lakes, and streams. Geosphere The geosphere is considered the portion of the Earth system that includes the Earth's interior, rocks and minerals, landforms, and the processes that shape the Earth's surface. The Earth itself, contrary to Christopher Columbus, is not a perfect sphere. Mineralogy.
Minerals are defined as solid inorganic natural occurrence substances with a definite chemical formula and general form. Almost all chemical elements in the earth are associated with at least one element. They vary in color, hardness, density of crystal, form, size, transparency, composition, location, and abundance. They are classified into mineral groups: native elements, halides, oxides, narites, sulfates, sulfites, and others. As obviously seen, it is composed of different varieties. These different groups represent each individual's differences, like the uniqueness of an individual characteristics.
Earthquakes.
So earthquakes are vibrations of earth produced by the rapid release of energy from rocks. The springing back of rock is called the elastic rebound. Small earthquakes called foreshocks often precede a major earthquake. There are two types of seismic waves. These are the surface waves and the body waves. The body waves are divided further into two, which are the primary waves and the secondary waves. The location on Earth's surface directly above the focus of an earthquake is called the epicenter. Seismologists use two fundamentally different measures to describe the size of an earthquake. These are the intensity and the magnitude.
Oceanography.
Oceanography studies all aspects of the world ocean. Oceanography has four main ocean basins, namely the Pacific Ocean, the Atlantic Ocean, the Indian Ocean, and the Arctic Ocean. Pacific Ocean is the largest and has the greatest depth. The Atlantic Ocean is half the size of the Pacific Ocean. The Indian Ocean is slightly smaller than the Atlantic Ocean. The Arctic Ocean is about 7% of the size of the Pacific Ocean.
Astronomy.
Astronomy is the study of sun, moon, stars, planets, comets, gas, galaxies, gas, dust, and other non-earthly bodies and phenomena. Hipparchus is the greatest of the early Greek astronomers, and he is the best known for his star catalogue. Aristotle concluded that the earth is spherical. Aristarchus is the first Greek to profess a sun-centered or heliocentric universe. Sir Isaac Newton was the first to formulate and test the law of universal gravitation, developed the laws of motion, and proved that the force of gravity, combined with the tendency of an object to move in a straight line or inertia, results in the elliptical orbits discovered by Kepler. Johannes Kepler ushered in the astronomy with his three laws of planetary motion. Anaxagoras reasoned that the moon shines by reflected sunlight, and because it is a sphere, only half is illuminated at one time. The first attempt to establish the size of the Earth is credited to Eratosthenes. Tycho Brahe's Observations were far more than any made previously and are his legacy to astronomy. Claudius Ptolemy presented the geocentric outlook of the Greeks in its most sophisticated form in a model that became known as the Ptolemaic system. Nicholas Copernicus reconstructed the solar system with the sun at the center and the planets orbiting around it, but erroneously continued to use circles to represent the orbits of the planets.
There are two mapping systems used to describe the celestial sphere. First is the division of the sky into areas or constellations, and the extension of Earth's lines of longitude and latitude into space or the equatorial system. Constellations are groups of stars that form a recognizable pattern and are traditionally named after mythological features. There are over 88 constellations recognized today. Astronomers use constellations when they want to roughly identify the area of the heavens they are observing. For students, constellations provide a good way to become familiar with the night sky. The equatorial system divides the celestial sphere into coordinates similar to the latitude and longitude system we use for establishing locations on Earth. The intersection between the plane that extends outward from the Earth and the celestial sphere is called the celestial equator. In the equatorial system, the term declination is analogous to latitude, and the term right ascension is analogous to longitude. Declination, like latitude, is the angular distance north or south of the celestial equator. Right ascension is the angular distance measured eastward along the celestial equator from the position of the vernal equinox. The vernal equinox is the point in the sky where the sun crosses the celestial equator at the onset of spring. Declination is expressed in degrees, while right ascension is expressed in hours. The two primary motions of Earth are rotation and revolution. Axial precession is a lesser motion. Rotation is the turning of the Earth in its own axis, while revolution is the turning of the body along a path around some point in space. Axial precession, on the other hand, is a gradual change in the orientation of Earth's axis over a period of 26,000 years. The Earth's rotation is measured in two ways, making two kinds of days. First and most familiar is the mean solar day, or the time interval from one noon to the next, which averages about 24 hours. Next is the sidereal day, or one complete rotation with respect to a star other than our Sun. The sidereal day makes up 23 hours, 56 minutes, and 4 seconds. Earth revolves around the Sun in an elliptical orbit at an average speed of 107,000 kilometers per hour. Its average distance from the Sun is 150 million kilometers. At perihelion, it is 147 million kilometers distant, which occurs about the 3rd of January each year. At aphelion, the Earth is 152 million kilometers distant, which occurs about the 4th of January every year. The apparent annual path of the Sun against the backdrop of the celestial sphere is called ecliptic. The planets and the Moon travel in nearly the same plane as Earth. Hence, their paths of the celestial sphere also lie near the ecliptic. The imaginary plane that connects points along the ecliptic is called the plane of the ecliptic. As measured from this imaginary plane, Earth's axis is tilted at 23.5 degrees. This angle is very important to Earth's inhabitants because the inclination of the Earth's axis causes the yearly cycle of seasons. A third and very slow movement of Earth is called axial precession. This movement is similar to the wobble of a spinning top. At present time, the axis points toward the bright star Polaris. The Moon is the Earth's only natural satellite. It orbits around the Earth about once each month.
Weather refers to the state of atmosphere at any given time and place, and it is constantly changing. Climate helps describe a place or region.
Just like the organs in our body, the four spheres would get affected if one of them gets harmed or destroyed. It's just like a domino effect. If one gets taken down, the others fall with it. Second application. Just like the classification of minerals, each one of us have different personalities and traits that make us unique in our own way, which makes us stand out from a crowd. Third application. Just like the ocean, we have our ups and downs in life. The tides may push our limits, but we have to stay firm in our faith so we won't get washed up. Earthquakes make us aware that the stillness we experience don't always stay that way, so we have to be aware and always be prepared and equipped with necessary knowledge. Last application. We learned that just like constellations, we are connected in a certain way as Christians because we are loved and blessed by God. Our home, our planet, our Earth. The Earth has been so good to us, yet we still continue to abuse its goodness despite all of the things happening in our world today. Studying all of these in our Earth Science class made us realize that our Earth is definitely like no other. No other planet can sustain life like Earth does, and no other planet will be as beautiful and as amazing as the Earth. There is definitely no place like home, so we must all take care of it. Although our planet is now changing and slowly dying, it's not too late to save it. Let us all treasure our Earth. Let us continue to discover new things about our planet and be constantly amazed by its beauty. Let us all be scientists. Let us not settle on the things we have learned. Let us all formulate hypotheses, theories, and conclusions and be curious.